Well, welcome to our third lesson on using the rules of exponents. And my video is a little bit different than the notes that you have. I've cut out the warm-up. I'm going to ask you to do the warm-up in your notes without putting that in the video. And so we're going to start with some vocabulary here. And it says in the expression x to the n, the x part is called the base, n is called the exponent, and the exponent tells us how many times to multiply the base by itself. And then we call the entire expression an exponential expression. So what happens if we have a negative exponent? How do we deal with that? Well, negative exponents, there's a rule for negative exponents that says that if n is a real number, as long as that exponent is a real number and x is a real number and x can't be 0, then when you have a negative exponent, that is defined as the reciprocal of that same exponential expression to the positive exponential power. So it's just the reciprocal of this one. So for example, x to the minus 3 would be 1 over x to the positive 3. So remember that our equations can be read backwards. You could start with the right-hand side and work to the left, or start with the left and work to the right. You'll see it in both ways. So in my own words, what this says is we can move an exponential expression to the other part of a fraction by changing the sign of the exponent. And what I mean by the other part means numerator or denominator. If you have a negative exponent in a numerator, you can move it to the denominator and make it positive. If you have a negative exponent in a denominator, you can move it to the numerator and make it positive. So here's a little bit of practice. So this says simplify the expressions. 1 over 5 to the minus 2. Well, what I just said was if we have a negative exponent in a denominator, if we move it to the numerator, it becomes positive. So that's the same as 5 to the positive 2, which we know is 5 squared, which is 25. On the second example, we have 5 to the negative 2. So now we're going to use that rule of exponents, and we're going to say, well, that's the same as 1 over 5 to the positive 2, which is 1 over 25. Letter C is very similar to letter B. The only difference is you get a negative answer. So it's the same as a negative out front, and then 1 over 5 to the positive 2. So we just keep that negative out front, and we get 1 over 25. Letter D, we have a negative exponent again, so it's 1 over negative 5, the quantity squared. When we square negative 5, we get 25, so it's 1 over 25. And letter E, the opposite of negative 5 to the negative 2. How many negatives can we throw in one expression here? The negative exponent says it's the reciprocal. The first negative stays out front, so we get negative 1 over negative 5 squared. When we square negative 5, we get a positive 25, but the negative stays out front. All right, so the product rule for exponents says this. If we have a base number, mn and x, if those are all real numbers, x can't be 0, and we have a base to the power m and the same base to the power n, then you keep the base and you add the exponents. So let's take a look at an example of what that looks like. The bases have to be the same. And so in simple terms, when multiplying the exponential expressions, keep the base, add the exponents. Here's some examples here of how to do this. So let's say we have all these y's, all these x's. Remember, anything that's negative goes in a denominator. So I'm just going to make a fraction bar here. And I see I have this y to the minus 4. I'm going to put that in the denominator and make it positive. Anything that's positive I will leave in the numerator, so y squared stays there. X squared stays there. There's a y up there. X to the minus 3, that's going to go down to the denominator and become positive. Y to the negative 2 goes to the denominator and becomes positive. And then x to the minus 5 goes to the denominator and also becomes positive. And then we can start canceling things or combining like terms. So let's just take a look at what we have here. Y squared and y, that gives me y to the third on the top. And x squared is going to stay where it is. I'm going to leave the x squared. It doesn't matter which order you put these. If they're x squared, y to the third, if you do it alphabetical or if you just do it in the order in which they appear. Either is fine. Remember, this is like y to the first power, so 2 plus 1 is 3. That's where that 3 came from. And then we're going to have an x term and a y term. I'm just going to line these up. Let's see how many y's we have. We have 4 and then another 2. So that's a total of 6. 3 and 5 gives me 8 for the x's. And our last step in here is to figure out, well, how many x's and y's do we have and where are they? Well, I have 3 y's in the top and 6 y's in the denominator. So what happens with this one, these 3 y's cancel with 3 of the y's in the denominator. So I'm going to lose 3 of those, but I'll have 3 left. These 2 x's will cancel with 2 of them down here, and I'll have 6 left. So my final answer is going to be 1 over y to the third, x to the sixth. If you had written this out longhand, I could have written y times y times y times x over, and then write y 6 times, 1, 2, 3, 4, 5, 6, and then 8 x's, 1, 2, 3, 4. And you see how tedious that is? We don't want to go through that. The y's, 3 of the y's cancel with 3 of the y's down there. You end up just subtracting your exponents as the shortcut of that, okay? So just wanted to show that to you quickly. Okay, letter B, let's go ahead and take a look at this one. So again, anything that has a negative exponent, I'm going to put in the opposite place. So this x to the minus 3 will go to the denominator and become positive. This x is already positive. Y squared is positive. It stays. X to the negative 1 is going to go down. It'll be x to the positive 1. Y stays there. X to the fifth stays there. Now let's work on the denominator. This y to the minus 7 is going to go to the top and become positive. X to the third stays there, and y to the fourth also stays there. So let's clean this up a little bit. How many x's do we have in the numerator and how many y's in the numerator? Well, let me go ahead and change colors here. Here's 1, here's 5, so that's a total of x to the sixth power. And then how many y's do we have? We have y to the second, y to the first. This is a first right here. So that's y to the third, and 7 more is y to the 10th. So that's what we end up with in the numerator. In the denominator, we have x to the third, x to the first, x to the third. So that's x to the 7th if we add them all up, and y to the 4th. And now we can simplify. We have 6 x's here, 7 x's here. We're going to be left with a single x in the denominator. Okay, so all of these 6 are going to cancel with those 7, and we're going to be left with 1 there, right? So that's x to the first. We have 10 y's in the top, 4 y's in the bottom. So we're going to end up with 6 y's in the top. So it's y to the sixth power over x. All right, the power rule for exponents says this. If we have a power to a power, so we have x to the m raised to the nth power, that says you multiply the exponents. Okay, that's different than the last one. The last one said if you have a base to a power and the same base to a power, you add them, but when you have a power to a power, those are multiplied. If you have multiple things inside your parentheses, every single thing in there gets raised to that power outside, so you multiply every exponent by that. So what does that say in simple terms? It says a base raised to more than one exponent, multiply the exponents. All right, the best way to do this is to go ahead and do some practice. So let's take a look at what we have with letter A here. All right, letter A, it says simplify. So here we have a power to a power. X is really to the first power, right? So when we multiply that, we get x to the first raised to the second. 1 times 2 is 2. Y to the third raised to the second. We multiply and get 6. And then we have x to the minus 4. I think I'll just go ahead and put that in the denominator right away and make it positive. And then this one we get x to the positive 6. Remember, a negative 2 times a negative 3 is a positive 6. And then we get y to the minus 3, and that's going to go down and become positive 3. So I've dealt with everything in the numerator. Now I'm moving down to the denominator. X to the first, y to the first. So we get x to the third when we multiply, y to the third. This y to the minus 4 is going to go up top and become positive, and then we have another x down here. So everything's multiplied. So we end up getting x to the 8th power in the numerator and y to the 10th all over x to the, looks like 7th power and y to the, whoops, I think I made a mistake here. Here's 4 and 3 is 7. There's one more right here, right? So that's an x to the 8th. So we need to correct that one right there. That should be an 8. Let's write that one in there. And then y, we get to the 6th power. We have y to the 3rd, y to the 3rd. That gives us y to the 6th. So now we can simplify this. X to the 8th and x to the 8th. Those completely cancel. Okay, they become 1. They're the same power. Y to the 10th over y to the 6th. These 6 will cancel with 10 of those. And we're going to have 4 left. So we're going to get y to the 4th is our final answer. All right, over on letter B, let's take a look at that one. We have x to the a plus 3. Nothing to simplify there. And then we're going to multiply that by, we have x to the b. That's just a dot, okay, kind of a messy dot. And then we're going to have y to the minus 2b. So I'm going to put y down in the denominator, y to the positive 2b. Okay, then we have x to the minus a. That's going to go up and become positive, x to the positive a. And y to the minus a down here would be up here as y to the positive a. Extend my fraction bar there. So what in the world do we have when we're finished? Well, let's take a look. We have a power of x. Here we have 3 bases that are the same. Remember, when the bases are the same, we add the exponents. So we have x to the a plus 3 plus b plus a times y to the a all over y to the 2b. This one's kind of messy. All right, so let's clean up this exponent here. This one's really x. We have 2 a's here, an a here and an a here. So it's 2a plus b plus 3 times y to the a. If I can fit that in there, I'm running out of room there. All over y to the 2b. So I think we could do one more thing. Let me extend my page here. Grab my arrow. So one more thing we could do to simplify that would be to write this as x to the 2a plus b plus 3 times y to the a, and then since this one is on the bottom, I could bring it to the top, and it's a minus 2b. That's probably as simple as we can make that. So that's pretty complex there. That was a tough problem. Scientific notation is actually an application of your exponent rules. So I thought we'd cover this right here. This kind of ties in with everything else. So if we have something like m times 10 to the nth, where we have an exponent on the power of 10, m has to be a number. Remember, in scientific notation, m must be a number between 1 and 10. It has to be less than 10 but bigger than 1. And then n tells us how many places that we move the decimal point. Okay, so that's kind of a summary of scientific notation. So what else do we know? When we write numbers in scientific notation, we can use the rules that we just talked about for exponents. So let's see how that helps us when we work problems. Well, here we have several numbers, not in scientific notation, but close, okay? Got some powers of 10 in here, so let's go ahead and clean this up and see what we get. Well, this number right here, just this piece without the power of 10, if we wanted to write that in scientific notation, that would be 3 times 10. Now this piece of the number is less than 1, so its exponent is negative. And how many powers, how many place values do we need to move it to make it a number between 1 and 10? 3 is the number between 1 and 10. So we've actually moved it 1, 2, 3, 4 places. So that's 3 times 10 to the minus 4. And then that's also multiplied by 10 to the minus 6. Okay, so 3 times 10 to the minus 4 is just this piece. Then we have the 10 to the minus 6. And then we're also going to multiply this by 4 times 10 to the, this would be 10 to the third, right? 4 times 10 to the third is 4,000. Okay, and then our denominator, let's take a look at that. This piece alone right here, the 0.006, is 6 times 10 to the, remember it's less than 1, so it's a negative exponent. How many places did I move it? I moved it 3 places. And then we have times 10 to the 15th. And 2000 is 2 times 10 to the 3rd. Okay, and then we also have a times 10 to the 4th out here. Well, we have a whole bunch of stuff going on here. Let's get our powers of 10 together and then our whole numbers together and see what comes out of this. So let's see, I'm just going to go ahead and circle some of these things. Our whole numbers are 3 and 4. If we multiply those, remember the commutative property says the order doesn't matter in which we multiply. So I'm going to go ahead and multiply the 3 and the 4 and get a 12. And then I know I'm going to have some power of 10. What is my power of 10? Well, remember if our bases are the same, we add the exponents. Negative 4 plus negative 6 is negative 10, and negative 10 plus 3 is negative 7. So that's what our numerator ends up being. In our denominator, this time I have a 6 and a 2. Well, that's kind of convenient, right? So we also have a 12 in the denominator. And what is our power of 10 in the denominator? We have a negative 3 plus 15. That gives us a positive 12. 12 plus 3 is a positive 15 again. So really these 3's cancel out. And 15 plus 4 is 19. So now what do? Well, the 12's cancel out. 12 divided by 12 is 1, right? And remember, when we have a negative exponent, it can go to the opposite place and become positive. So really what we have is 1 over 10 to the 7th times 10 to the 19th, and that is really 1 over 10 to the 26th. And you always want to write your answer with a positive exponent whenever possible. So rather than write that as 10 to the minus 26, you can write that as 1 over 10 to the 26th. All right, we're almost there. Here's one for you to try. Go ahead and pause the video on this one, see if you can come up with your own answer. And I think we'll just pass through this on the video. I'll check this in class. So see if you can get this one on your own, since I just did the last one. I'm going to keep going here. For your last slide here, it says the maximum distance of the Earth from the Sun is a big number there, 152, what is that, a trillion maybe? And meters, how many seconds does it take light to reach the Earth from the Sun if the speed of light is 3 times 10 to the 8th? Well, the thing you need to know about this one, right, you need a formula to do this. And the formula that you should know is distance is rate times time, right? What are we looking for? It says how many seconds. We're looking for time is our unknown. We're given a distance. So let's write this distance in scientific notation. Where would our decimal point go to make that number be between 1 and 10? Where is our decimal point going to go for this number? Well, our decimal point is going to go between the 1 and the 5, right? That's where it's going to go. So we're going to write that for distance 1.52 times 10 to some power, right? And what is 10? Well, what's our exponent on 10? How many places did we move it? We moved it 3, 6, 9, 10, 11, right? So it's 1.52 times 10 to the 11th is equal to, our rate is the speed of light, right? That's meters per second. That's a rate. So that's equal to 3 times 10 to the 8th. And then that's multiplied by time. We want to know the time, right? So we're trying to solve for t. So if I want to know what t is, I need to divide both sides by that rate. So let's go ahead and divide this side and this side by 3 times 10 to the 8th, 3 times 10 to the 8th. And I'm going to move down here a little bit so we have a little bit more room. So over here, these are going to cancel, right? Anything over itself is 1, and I have t is equal to. If you take 1.52 and divide it by 3, you end up with 0.506, and I believe the 6 repeats. And then we're going to have a power of 10 times 10 to the 11 is on top, 8's on the bottom. 11 minus 8 is 3, are left in the numerator. Well, we can write that just as a whole number. If we move this 3 places, right? If we multiply that power of 10 out, we get 560 actually I'm going to round that up, 507 to be closer to the exact. 507 seconds is how long it would take the speed of light to get to the Earth. So there you go. All right, that's it for this video. See you in class.